find the sixth roots of z equals minus 64 and graph them in the complex plane. So we're going to find 6 roots, so this could be quite time consuming. We start by trying to put z in cis form. So we're going to need an Argand diagram. So there is the imaginary axis and the real axis. Real, imaginary. So this is purely real and it's at minus 64. Okay, so you can see the argument is pi. Okay, so the modulus is 64, the argument is pi. So z equals 64 cis pi. But I'm not going to write 64 cis pi, I'm going to write 64 cis pi plus k2 pi, where k is an integer. The reason is if we just write 64 cis pi, then when we take the 6th root of it, we use De Moivre's theorem, we're only going to get one answer, and I want 6 answers. So I need to be able to adjust the value of k, so I can get to my 6 answers. Okay, so we want to find the 6th root, so we need z to the power of 1 over 6. So that equals 64 to the power of 1 over 6, so that's the 6th root of 64. Cis, well, okay, if we are raising a complex number in polar form, cis form, modulus argument form to a power, then we raise the modulus to that power, which we've already done with the 6th root of 64, and then we multiply the argument by that power. So the power is 1/6, so we now need to do cis pi over 6. We're multiplying by a 6th, so we're dividing by 6. So pi over 6 plus k2 pi by 6. Okay, where k needs to be an integer. Okay, the 6th root of 64, I'm very much hoping it is 2. It's 2 to the power 6. So 2 squared is 4, so you've got 2. 2 squared is 4, 2 cubed is 8, 2 to the power 4 is 16, 2 to the power 5, 32, and 2 to the power 6 is 64, so that's good. So it's 2 cis pi by 6 plus k2 pi by 6, where k is an integer. Okay, so now we just need to use any 6 consecutive integers and we will get 6 nicely spaced answers out, and then we'll represent them on the diagram. I'm just going to use k equals 0, 1, 2, 3, 4, 5. You could potentially be creative and use -2, -1, 0, 1, 2, 3, something like that. I'm just going to use 0, 1, 2, 3, 4, and 5. So let's k equal 0. That would mean our first root, which I'm going to call W1, it's a standard way of writing it, is going to be, well, it's 2 cis pi by 6. Okay, if we let k equal 1, the second root, W2, is going to be 2 cis, well, it's pi by 6 plus 2 pi by 6, that's 3 pi by 6, which is pi by 2. Okay, let k equal 2, so that would mean the third root, W3, would be 2 cis, well, you have pi by 6 plus 2 times 2 pi by 6, so that's 4 pi by 6 plus 1 pi by 6, that's 5 pi by 6. Okay, let k equal 3, so the fourth root is going to be 2 cis. If k is 3, well, here you've got 3 times 2 is 6, so 6 pi by 6 plus pi by 6 is 7 pi by 6. Okay, we need to find 2 more. We've already got 4 roots, so let k equal 4. Okay, so the fifth root, W5, would be 2 cis. Now we are getting to big numbers, maybe we should have used some of those negatives. But we have 4 times 2 is 8. 8 pi by 6 plus pi by 6 is 9 pi by 6, which is 3 pi by 2. 3 pi by 2. And the last one, let k equal 5. So the sixth root, W6, equals 2 cis. So if k equals 5, in here you've got 2 times 5 is 10, so 10 pi by 6 plus another pi by 6 is 11 pi by 6. Okay, so we're going to attempt to draw these on an Argand diagram. I think I am actually going to draw a nice circle. As you remember, all of these roots are complex numbers, and they all have a modulus of 2. They're on 2 cis something, so it's 2 cos theta plus I sine theta. They could all potentially, with these nice numbers, we could even convert them to Cartesian form, but because we've just been asked to represent them on the diagram, it's much easier if you have the argument, because then you can space them out nicely around a diagram. So let's try and draw a nice circle. And the imaginary axis and the real axis. Real, imaginary, and this has a radius of 2. So 2, minus 2, minus 2, and 2 up there. Okay, so the first root, W1, is 2 cis pi by 6. So just think, pi is 180, pi by 6 is 30. So the first root is 30 is probably about there. So that is W1. Okay, the second one is 2 cis pi by 2. Well, pi by 2 is 90 degrees, so that can be here. So probably could do with a different colour, but that is W2. The third root is 2 cis 5 pi by 6. We said pi by 6 is 30, so 5 3s are 15, so it's 150. It's basically 30 less than 180, so it's there, W3. The fourth root is 2 cis 7 pi by 6. Pi by 6 is 30, 7 3s are 21, so it's at 210, which is 30 degrees more than 180, so that's here. And that is the fourth root, W4. The fifth root is at 3 pi by 2, or pi by 2 is 90, 3 9s are 27, so it's actually here, 270 degrees, so that is the fifth root. And the sixth root, 11 pi by 6, well, pi by 6 is 30, 11 3s are 33, so it's 330 degrees, which is 30 degrees less than 360, so that is down here. And that is W6, okay? So we could then put all these arguments in. I probably should have done it before. So the first one, this was pi by 6. In fact, if I put all of these angles in, it's going to be quite confusing. But one thing you do need to note is there's 6 of these roots. So 360 divided by 6 is 60 degrees. So they should all be 60 degrees apart. You could also say, well, 2 pi divided by 6 is pi divided by 3. So they should be exactly between all of these roots. You should have 60 degrees or pi by 3 radians, pi by 3 separating each root. Every time you do this, your roots will be nicely symmetrically spaced around an Argand diagram.